Now, we want to be careful here. So if I were to go, what I did the first time I was trying to solve this was I tried to go to joint 5 next. And what I found is that because joint 5 has 5 different members, there were too many unknowns for me to solve. So for example, like I know what F and G is, but I don't know what I and K and J are. So 5 was a little bit difficult. So at this point, if you ever get to a joint like that, where there's too many unknowns, it just means that you need to start with some easier ones first. So we're going to leave joint 5 for now, and we're going to go to easier ones. So I'm going to start from this side, and 9 looks like a really easy joint to make. So just these two members. Okay, so let's look at joint. Draw the joint itself. Got two kips going down. We've got Q. I've got M. Okay. So sum of the forces in the y direction equals 0. And let's see what we got. We got -2 kips. And I'm going to guess that Q is in compression. It's going up against the 2K. So plus Q. Can move the 2 kips over and say that Q is equal to 2 kips. And I got a positive answer, so it means that my assumption was correct. My assumption was that it was in compression. Okay, so I can color that red for compression. And now let's do some of the forces in the x direction are equal to 0. And what do we have? Well, we just have n. So since it's by itself, that means that n is equal to 0, and it is in neither tension nor compression. It's 0. Okay. Next, let's move on to joint 10. Joint 10, let's see what we got. Well, draw the point itself. And at joint 10, we've got Q, got O, we've got P. Well, Q, I know from before that that's in compression, so it's going to be pushing down towards the joint. And these other ones I'm not sure about yet. So sum of the forces in the y direction equals 0. And let's see what I got. I got -Q. And then I've got O over here. And I'm going to guess that O is going against Q because it's the only other force in the vertical direction. We got to get to 0 somehow. I'm going to guess that O is in tension. And I'm going to say, because we're sum of the forces in the y direction, this is diagonal. I just need the y component. So I'm going to say plus, because it's going up, OY. So I can move the Q over and say that OY is equal to Q, and Q is 2 kips. So, and I got a positive answer. So that means that O, my assumption was correct about O, and O is in tension. Color it blue. Okay. Now to solve for O itself. Now draw that triangle. O, O, Y, O, X. And these are 45 degrees. Again, we know from the problem. And because of that, I can say OX is equal to OY is equal to 2K. And then if I want to get O, we use the Pythagorean theorem. Say A squared plus B squared equals C squared. OX squared plus OY squared equals O squared. 2K squared plus 2K squared to O squared. And that's going to be 4K plus 4K is equal to O squared. And then O is equal to the square root of 8K. And that means that O is going to be 2.83. And from before, I found the direction of O, and so I know that it's going to be in. But now we still got an unknown in the X direction, which is P. So let's look. Let's do sum of the forces in the X direction equal to 0. And we have O, the X component of O moving to the left. So I can say negative OX. And then P, I'm thinking that I'm going to have to counteract OX because those are the only two forces and got to get to 0 somehow. So I'm going to guess that P is going to be in compression, be like pushing against the point, while O is pulling away from it to counteract each other. That's my guess anyway. So I'm going to say negative OX plus P. So they're in opposite directions. And I can move OX over, so P is equal to OX. And we know OX is 2K, so P is equal to 2K. And I got a positive answer, so that means my assumption is correct. My assumption was that P is in compression. In color. Oh, next, let's look at joint 7. All right, so draw the joint first. 2 kips, it's coming down. There's M, there's J, there's N, and there's O. Okay, let's see what we know. Well, we know O is in tension. So it's going to be pulling away. We know we know the n is 0. And that's about it. Now we can say sum of the forces in the y direction is equal to 0, equal to negative 2k. And we got O going down, so minus OY. And then there's M. And I'm going to guess that if this 2k is going down and this O is going down, well, gotta get to 0 somehow. So M, I'm going to guess is in compression, is like counteracting it. I'm going to say plus M. So I can move these things over and say that M is equal to 2k plus OY. And I know that OY is 2k, or 2k plus 2k, M is equal to 4k. And I got a positive answer, which means my assumption was correct. My assumption was that M is in compression. So I can color it red. Okay, good. Now let's do sum of the forces in the x direction are equal to 0. And what do we have? Well, we have n. We have OX, and OX is kind of going this way. So I'm going to say plus OX, and then J. And I think that since I know N is 0, and so the only horizontal forces really are J and OX. OX is going to the right, so I'm going to guess that J is going to the left to counteract it. So that would be J is in tension. So I'm going to say minus J. 0 is equal to N is equal to 0 plus OX, which is, let's see, where's OX? Over here. Over here is 2K. That's 2K minus J. And move the J over and say J is equal to 2K. I got a positive answer, which means my assumption was correct. My assumption was that J is in tension. So I can color it blue.